Hello, this is question 4 from the 2012 MAT. Diagram below shows the parabola y equals x squared and a circle with centre 0, 2 just resting on the parabola, which means that the circle and the parabola are tangential to each other at points A and B. Okay, let x, y be a point on the parabola such that x is not equal to 0, so not the vertex, so not the origin. Show that the gradient of the line joining this point to the centre of the circle is given by that equation. Okay, so let's take some general point on the parabola. So let's go there, call that xy. We've got the centre at 0, 2. We just need that gradient between them. So changing y over changing x is y minus 2 over x minus 0, and y is x squared. So x squared minus 2 over x. Okay, right, that's got us warmed up. Part 2, with the help of the result from part 1 or otherwise, probably not, show that the coordinates of B are given by this. So we're now bringing that point to B. Now we know at B, we've now got a tangent. So we've got these perpendicular lines here. So at B, the gradient of the parabola, which is 2x, is going to be equal to the negative reciprocal of the gradient of the radius. So all of that. We also know x is not equal to 0, so we can cancel these x's, which helps. So we've got 2x squared. We're then going to get a minus 4. Put that back on the other side. Give us a 4. Take off 1 is 3. So x squared is 3 over 2, which, oh, well, that is y, isn't it? And then that means that x is going to be the square root of 3 over 2. Right, excellent. Part 3, show that the area of the sector of the circle enclosed by the radius to A, so that's that line, the minor arc AB, so the short way round to B, and then the radius to B, so that line. So we need the area of that. Right, and it's got a cos in it. Well, these are usually best to split into right angled triangles, so we'll make that a theta. So the area then is going to be 2 theta over 2 pi times pi r squared. So lots of things are cancelling there. So theta r squared. So we've got that for our area. We know that B is at these coordinates, so that's going to help, isn't it? So r squared is going to be x squared, so that's 3 over 2, plus the change in y squared, which is 2 minus 3 over 2 squared. So that's a quarter, which is then 7 over 4. So that's our r squared. Now that's good. So we just need theta and we're done. And they've gone for cos in the answer. So cos theta is going to be our adjacent, which is what, a half, divided by r, so 1 over 2r, and r we've got as being root 7 over 2, so 2r is root 7, and yeah, we just got 1 over root 7 then on that. So we put all this in, we should be fine. So the area is r squared, which is 7 over 4, and then theta, which is inverse cos of 1 over root 7. Right, that was fine, I think. Right, yeah, we got more. Suppose now that a circle with centre 0a is resting on the parabola where a is greater than 0. Find the range of values of a for which the circle and parabola touch at 2 distinct points. Okay, so what's happening here is, right, so we want it to be resting at 2 points. They've changed the centre, so we've done a test case here for A is 2, essentially. And yeah, if you reduce A down, eventually we're going to get to a point where it's just sitting there at 0, 0. It's going to sit at the vertex at some point. So we're now having to work out when that's happening. So what have we done? We've sort of done this, haven't we? Because we've done, we worked out this gradient. We worked out the coordinates of B. So we do it again with an A rather than a 2. And say, well, we don't want our x coordinate to be 0. and then we're fine. Yeah, so yeah, we just do that again then. So what is the difference going to be on this then? So that 2 is going to become an a, isn't it? So we're going to have an x squared minus a over x. Okay, so we've now got x squared minus a over x, and that has to be, well, minus 1 over 2x for the parabola, and we need to solve that for x not being 0. Well, in fact, x being positive, greater than 0. So for x greater than 0, and we know that a is greater than 0 as well. Okay, so that means we can multiply by x because it's not 0. So we're getting that x squared is equal to a minus a half. Okay, and x is greater than 0. So, and a is also greater than 0. So a is going to have to be greater than a half. Because, yeah, if it's anything between 0 and a half, then x squared would be negative, which we can't have. So, okay, so we got a is greater than a half. Then, is that all we have to do on this? Find a range of values for a for which the circle and parabola touch at 2 different points. Yeah, okay, there we go. So part 5, let r be the circle radius of a circle with that centre 0a resting on the parabola. Express a as a function of r, distinguishing between the cases in which the circle is and is not in contact with the vertex of the parabola. So, oh my word, can't get my words out. Vertex of the parabola. So we'll say is in contact and is not in contact. So we need a as a function of r. So if it is in contact, so that's our parabola. If it is in contact there, then we've just got a circle, and well, a is equal to r. That is our a. That's our y coordinate, which is also the radius. So if it is in contact, that means that we've got a is greater than 0, less than or equal to a half, and then a would be equal to r. If we are not in contact with the vertex, so we've now got 2 points. So if we've got 2 points, then we've got, so this is our a is greater than a half. So our r squared, radius squared, is going to be equal to the, well, x squared plus y minus a squared. So we know that. We also know that x squared is this, so we've got that, and we know that y is x squared because this got a lie on the parabola. So we've got x squared, so it's a minus a half plus y is x squared, so another a minus a half minus a squared, so they'll cancel. So we've got a minus a half then plus a quarter, so a minus a quarter is equal to r squared. So there, well, we've just got a is r squared plus a quarter. Okay, right, that fell through relatively straightforwardly. Not exactly a trivial question, but they broke it up into pretty manageable chunks, really, I would say, with that one. So quite a nice one, though. You know, again, geometry ones, okay, coordinate geometry is not maybe as exciting as the real thing, but it's not too bad. So didn't mind that question.